All right, so again, your quiz on Monday will be a handout. Your front page will be graphing. Your left side will be the logarithmic growth or decay, and then your right column will be the other type, growth or decay. So we did logarithmic growth parent function here on part A yesterday, and now we're doing it looks like logarithmic decay, right? You see a log function in there, and the base is 1/2. So the first thing I'm going to do is come over here and I'm going to look at my PF, my parent function. It's y equals log base zero point 0.5 or 1/2, whatever you're more comfortable with. And that has a vertical asymptote on the y-axis, and it has a y-intercept at 1, 0, just like all log functions of the form log base b of x. Okay. The only difference is because it's less than 1, it's logarithmic decay to start with. So it looks like this. Oh, my stylus is not cooperating. It's sketchy this morning. I'm gonna try logging out and logging back in. Okay, so it looks like that. Now I need to put it in the standard transformation form because it's not. So the 1 in the front goes to the back. So it's 1 of log base 0.5 of, and the plus 1 goes back there. Now remember on the inside, that's where we might have to do a little bit more work. The first thing I want to do is put the x term first. So when I commute the terms, I get negative x plus 4. Is that standard transformation form? No. I need to factor out the negative on the inside. So that, remember, looks like this. Negative parentheses, x minus 4, close, close, plus 1. That's standard transformation form. So on the quiz, you'll get a check for that. Do you have it in standard transformation form? I'll bring down the a of x. Yeah. Uh-huh. Yeah. Just like that. Now, we can go ahead and describe the sequence here. So I'll do that right here. The sequence, what does the 3 do in front? Vertical stretch by a factor of 3. Very good. Number 2, this is probably one of the more important ones. The negative in front of the x is a what? That's a y-axis reflection. Y-axis reflection. So the vertical stretch by a factor of 3, we don't really need to show. It's just going to make it steeper. But when I reflect it across the y-axis, which is where the vertical asymptote is, it's going to look like that, doesn't it? So now it turns into a growth function, and most importantly, it lives now to the left of the vertical asymptote. What does the minus 4 do? It moves it right 4, so R4, and then the last one plus the fourth one is plus 1. That's up 1. So the two most important transformations are those two right there. Because when I sketch my final graph, it's going to move it right 4. So that's going to be 1, 2, 3, 4. There's my new vertical asymptote. And where is my old x? I don't have to really show the x-intercept. I'm not quite sure where it is because I did move it up. But I know it's going to have this shape right here. It looks something like that. Okay. Now, let's go ahead and find the y-intercept first because I may, since I moved it up 1, the graph, if it's moved up enough, notice, can have a positive y-intercept. You see that? It's nice that we could do this with Notability. We can animate it. So if I move it up enough, there's going to be a positive y-intercept. It could be that it passes through the origin, or if I didn't move it up enough, it still has a negative y-intercept. So let's find the y-intercept first. So we're going to do a of 0. That's how we always show that we're finding the y-intercept. And I'm going to plug it into the original version. It's just a little bit easier. So I'm going to get 1 plus 3 log base 0.5 of 4. Okay. Now, I need to think if that's positive or negative. Log, let's come up here and think of log base 1/2 of 4. 1/2 to what power is 4? It's going to be negative 2, right? The negative is going to flip the 1/2 and make it 2, and then that's going to square it. So that's actually negative 2. So this equals 1 plus 3 times negative 2, which makes it 1 minus 6, which is what? Negative 5. Okay. So do I have it graphed correctly? Yeah. So on the quiz, you're going to get a check for having the y-intercept. And make sure you have the right notation. Make sure you have a of 0. I'm still impressing upon you the importance of the notation. Hopefully that's second nature to you now. But I have it graphed in the right spot because it's crossing in negative land. So then let's find the domain. The domain from the graph, it looks like it's everything to the left of 4. So it's the set of all x such that x is less than 4. That, of course, will get a check. You could put D or you could put D sub A if you want, but D is important. The range is easy. What's the range? All real numbers. Yeah. We found the y-intercept already. I wouldn't ask you about the right-end behavior because there is none. There's no graph. But the left-end behavior, I could. The limit as x goes to negative infinity of a of x is what? Negative infinity. Very good. As you go to the left, it goes down forever. And that's pretty much, you would get a check for each of those, of course. Domain, range, limit. You would get a check for the vertical asymptote. You would get a check for the shape. And I might give you another check for having the right y-intercept shown in the right vicinity. So there's lots of checks involved, okay? Standard transformation form, vertical asymptote, shape, y-intercept value, domain, range, and end behavior. 1, 2, 3, 4, 5, 6, 7, 8. 8 checks for that one thing. Very, very important. Now, let me show you another way you can find the domain. This is very, very important right here. We'll put this in a little box. To find the domain of a log function without having to graph it. Without the graph. It was very helpful to have the graph here, but really it comes down to where the vertical asymptote moved and whether it lives to the left or right of it. All you got to do is this. Remember when we have log base b of what I call the argument. Right? Whenever we take the log of something, the thing that we take the log of is called the argument. All you have to do, if you want to algebraically find the domain of the function, let me go ahead and say that up here, algebraic domain of the log function, all you got to do is take the argument and say it has to be greater than 0. Not greater than or equal to 0 like we do for radicands, but strictly greater than 0. We can only take the log of a positive number. That's it. We can only take the log of a positive number. We can only take the log of what type of number? Positive number. Okay, so if this were a multiple choice question on the test, and I just asked you for the domain, you could either A, graph it, spend all the time graphing it, and say, oh, it's everything to the left of 4, or you could do this. Watch. You could say the argument, which is 4 minus x, has to be greater than 0. 4 minus x has to be greater than 0. And if we solve that, we get negative x is greater than negative 4. And what do we have to do if we multiply or divide by a negative to the inequality? We flip it, so that becomes less than, and then a negative times a negative is positive. Is that the right domain? What we got from the graph? It is. Yeah. Same thing. Same thing over here. If you wanted to find the domain, you just say x plus 4 is greater than 0. So x is greater than negative 4. That's the same thing we got yesterday. So finding the domain of a log function can be found 2 ways, right? We can find it algebraically now, and of course we can find it graphically. It's good to find them both ways and compare them because they should match up with each other. All right, comments or questions on example 7? Sketching graphs. All right, example 8. Look at this. Find the domain of the following functions. I don't think I want to sketch these graphs, so we're going to do it the way I just taught you, which is algebraically. We're going to sketch it algebraically. So I have 3 minus 4 natural log of x squared minus 9. I can't put this one, I can't even graph this one because I can't put it in the standard transformation form because I'm not taking the log of ax plus b. I'm taking the log of x squared minus 9. I don't know how to sketch that because it's a quadratic inside. But I do know how to find the domain. I know that x squared minus 9, the argument, has to be what? Greater than 0. So if this is a quiz question on Monday, you would get a check for setting up your inequality. Now, question to you. Can I solve that inequality algebraically? No. We've talked about this earlier in the year. The only type of inequalities I can solve algebraically are the linear ones, like we did up above. And even then, I have to remember to flip the inequality when I multiply or divide by a negative. So how do I solve these if they're not linear? Well, I can factor, yeah, x minus 3, x plus 3. That'll work. But can I do this? Can I say x minus 3 is greater than 0 or x plus 3 is greater than 0? Does that work? No. That's where it fails. That's trying to solve it algebraically. you have to solve it graphically. You remember that? You got to solve these graphically. So I know that my function is a parabola that opens up. Would you agree? X squared minus 9? That's a parabola that opens up. In fact, if I were to sketch it, I know the y-intercept down here is negative 9. I know the y-intercept is negative 9, and I know it opens up like this. I just need to find the x-intercepts. I need to know what those are. That's why I can factor it. As long as I don't set each factor greater than 0, I can have it factored, the whole thing greater than 0. But that just means that the roots, or the zeros, are x equals plus or minus 3. So this must be negative 3, and this must be positive 3. And then remember, we return to the inequality. I want to know where that graph is greater than 0. Greater than 0, does that mean above the x-axis or below the x-axis? Above. So I want to know where it's above the x-axis, which, remember, for a parabola, it's either going to be everything between the x-intercepts or everything outside the x-intercepts. Does that ring a bell? Yeah. So for this one, what's the solution? Everything between the x-intercepts or everything outside of? Everything outside of. So our domain of f is going to be the set of all x such that x is less than negative 3, strictly less than, or x is greater than 3. It's outside the x-intercepts. Or if you like interval notation, you could say x epsilon, negative infinity to negative 3, union 3 to infinity. These make good questions on the quiz because they're kind of review questions. Once you set up your inequality, it's solving a quadratic inequality, which is a review question. We did that last semester. Okay, real quickly, what are the only types of inequalities we can solve algebraically? Linear. But even then, we have to remember to change the inequality when we multiply or divide by a negative. Linear is mx plus b. All right, let's look at letter B. I have g of x is 2 plus log of 2 minus the square root of x. I want to find the domain. So I take my argument, 2 minus the square root of x, and I say it's greater than 0. Can I solve that inequality algebraically? No, because it's not linear. So I need to solve it graphically. Now this one is not a parabola. So let's go ahead and set that equal to y. We'll say y is equal to 2 minus the square root of x, which, when I put it into standard transformation form, is negative square root of x plus 2. Do I know how to sketch that simple transformation of my parent function, radical x? Yeah. Remember radical x, square root of x looks like this. It comes out of the origin and looks like that. Right? That's your parent function, your PF. So what would the negative do to it? X-axis reflection, and the plus 2 would move it up 2. So I should have a genesis point, as we call it, right here, and then it should go down and to the right. Looks something like that. I want to know where that graph is positive. I want to know where that graph is positive. Now, if you look at your graph, you can see that it's positive right here on this little stretch that I highlighted. See that? So I know it's positive at 0, and then the graph is positive everywhere starting at 0 up to that x-intercept right there. So I need to figure out what that x value is. How do I find an x-intercept for any function? Y equals 0. Very good. In other words, I need to set my entire function equal to 0, and I need to solve. I need to find the x-intercept. So I set the whole thing equal to 0. Now, because it's an equation and not an inequality, I can solve this one algebraically, right? So I'll just bring the 2 across and it becomes negative 2. I multiply both sides by negative 1, and I get square root of x equals 2. And how do I unsquare root something? I square it. So I get x equals 2 squared, which is 4. So there's the x-intercept. Now looking at the graph, I can state the domain of G is going to be the set of all x such that, and because it's at a compound inequality, it's going to be 0 less than or equal to x less than 4. Or if you like interval notation, you could say x epsilon 0 with the bracket all the way up to 4 with the parenthesis. Why can I include 0? It's the genesis point, and that's where the graph is positive, right? The graph is positive there. I can only take logs of positive numbers, and it is positive there. Why can I not include 4? What's the value of the function at 4? 0. Can I take the log of 0? No. I can only take the log of a positive number. So that one is a partially open or partially closed interval.
So 0.
Log of 0 is your vertical asymptote. That's what the vertical asymptote is. Okay? All right. You got the idea? Those are both good review questions. Once you set up the inequality, it's just a matter of sketching by simple transformations. Okay. Then we get to example 9, which spices it up even a little bit more. H of x is 3 log base 4 of, not times, of log base 5 of x plus 8. Part A, find the domain of h. Well, what am I going to do? Well, I have two things to consider here. If you look at the innermost log, it has an argument of x, doesn't it? So if I just treat that one by itself, I know x without a highlighter, stupid me. I know x has to be greater than 0. Yes, yes? That's part of the requirement. It's not going to work if x is not greater than 0. But the log base 5 of x itself also has to be greater than 0 because it's the argument on the log base 4. See that? Now I got to solve that inequality. Can I solve that one algebraically? Is that linear? That is not linear. So I need to solve that graphically. I need to solve this one graphically. So if I set log base 5 equal to y, I know what the graph of log base 5 of x looks like, don't I? That's just a real straightforward log function. It has a vertical asymptote right there. And where's the x-intercept? What's the point right there at the x-intercept? 1, 0. Yeah. Now because it's base 5, it's monotonic increasing. So it looks like that. So if I look at the graph and now I return to the inequality, I want to know where it's greater than 0. Greater than 0 means positive. I can see that this graph is positive above the x-axis, which is to the right of what x value? To the right of 1. Yeah. So that's the domain of that piece. Now, to be the domain of the function, it has to satisfy both of them, right? I can't have two different inequalities. I can't say the domain is everything greater than 0 and everything greater than 1. It has to work for both of them. So which one of those includes the other? 1. Very good. Anything that's bigger than 1 is automatically greater than 0. But there are numbers bigger than 0 that aren't bigger than 1, right? Like a half, 2/3. So I have to take the one that works for both. So the domain of H is the set of all x such that x is greater than 1. That'll take care of both of them.
Why wouldn't you use greater than or equal to? Because if it also includes 0.
Well, if it's equal to, then remember we're going to be taking the log of 0, and we can't take the log of 0. So these are strict inequalities. Yeah, yeah. All right. Here's something that was similar to, I think, a question in your homework. I was going over with Peyton this morning. I want to find the inverse function of h of x. So if you remember how to find the inverse function, you interchange x and y, then resolve for y. That's how you find the inverse of a function. So let's bring my function over here, and instead of h of x, I'm going to call it y. So y equals 3 log base 4 of log base 5 of x plus 8. All right, here's the money step. I'll use green. The money step is when you interchange x and y. So we get x equals 3 log base 4 of log base 5 of x plus 8. Oops, I didn't change that one. That one's supposed to be a y. All right, now I got to resolve for y. So all I'm doing now is I'm peeling back the layers. I'm trying to peel back the layers by doing inverse operations. What's the first thing I would have to do here? I would have to subtract 8. I need to isolate the variable term. So I need to get rid of the 8. So that becomes x minus 8 equals 3 log base 4 of log base 5 of y. Now that I have the variable term isolated, I need to start peeling back the factors or the operations that are in front of the y. What's the thing that's out in front that I need to get rid of? The 3. So I divide both sides by 3. Yeah, very good. So I'll get x minus 8, all of it divided by 3, and that's going to equal log base 4 of log base 5 of y. So far, so good. Peeling back the layers. Now I'm faced with log base 4. How do I unlog base 4 something? Nope. The word we learned yesterday was exponentiate. Exponentiation undoes logging. So I'm going to put a 4 here and a 4 here on the bottom left so that each side is now an exponent. Remember that from yesterday? All right, so on this side, I'm going to get 4 to the x minus 8 over third power. And what do I get on the right side? What's 4 to the log base 4 of blob? It's the blob, which is log base 5 of y. Yeah, I'm getting closer, right? Now, normally we'd be done. If we didn't have another log function, we'd kind of be done at this point, or maybe we'd add or subtract something to both sides. But in this case, I need to unlog base 5 something. How do we unlog base 5 something? Exponentiate base 5. So I'm going to have kind of like a laddered structure on the right-hand side, or on the left-hand side. So 5 to the log base 5 of y is going to be y. I'll put that on the left, and I'm left with this. Watch. 5 raised to the fourth power raised to the x minus 8 over third power. Yeah, you could do that. So it's a triple decker. All right, triple decker. It actually has 4 layers if you think of the final exponent being a quotient. All right, and then the last thing you could do if you want is you could call that h inverse of x. You can give it the fancy name h inverse of x. Okay, so that's how you find the inverses of a function. You interchange x and y, and you resolve for y. You log something to exponentiate something, and you exponentiate something to unlog it. Okay, one undoes the other. One undoes the other. Good morning. Happy send-off day. Yeah. Oh, thank you. You're so kind. All right. Any questions on example 9? All right. I'm going to let y'all do 10 as a warm-up or a cool-down exercise while I scarf these free breakfast tacos. No, I'll save them for later. All right. The last question. Example 10. If f of x is 2 log base a half of 2x minus 4 plus 3, find the domain of f. Okay, this makes kind of like a good free response question. Find the domain of f. Do we need to graph it to find the domain? No, we don't have to graph it to find the domain. I see the argument is 2x minus 4. I see it and I set it what? Greater than or equal to? Strictly greater than 0. Can I solve that one algebraically? Yes, because that's linear. That's linear. So I'll just bring the 4 across. I'll divide through by 2, and I get x is greater than 2. And then I just short up in the answer. So I'll say the domain of f is the set of all x such that x is greater than 2. Yeah, there you go. Package it up in set notation, set builder notation. Easy. It didn't ask for the range. That would be easy too. Or does it ask for the range? Oh, on part D, let's jump to part D. What's the range of f? All real numbers. Okay. We don't have to necessarily answer them in order, do we? No. Okay. Oh, look, let's do C. The domain of f inverse. I haven't even found f inverse yet, have I? All real numbers. How do you know that?
It's like the range is the domain, and the domain is the range.
Very good. Remember, when you find an inverse of a function, the domain and range switch places. All of the x information becomes y information. So the domain of f inverse is the range of what? Of f. The domain of f inverse is the range of f. Didn't we just find the range of f? We did. So we're going to say the domain of f inverse is all real numbers. Now, all that's left to do is to find the inverse itself. So to find the inverse itself, this is going to be kind of easy since we already did example 9b, but we're going to interchange x and y. So instead of f of x, I'm going to call it x equals 2 log base 1/2 of 2y minus 4 plus 3. So I went straight to the money step. I interchanged x and y. Now we just peel back the layers, right? We're used to this. I subtract 3 first. Yes, yes. I got to isolate the variable term. So I get x minus 3 equals 2 log base 1/2 of 2y minus 4. Okay, got that. Now that I have the variable term isolated, I need to isolate the variable factor. So if I walk up to this from the outside, the first guy that I come into contact with is the 2. I need to get rid of it. It's multiplied currently, so I divide it to get rid of it. So that's the inverse operation. So the 2 is gone now, and I have a divided by 2 on the left-hand side. All right, now I walk up to it, and I'm facing a log base 1/2. How do we unlog something base 1/2? Exponentiate it base 1/2. Good. And you can show that by doing that, like that, on your paper. On the right-hand side, those are going to go away, and we're just left with 2y minus 4. Over here, though, we're left with 1/2, and I would put parentheses. Since the base is a fraction, we typically put parentheses there. Otherwise, we might think it's associated just with the 1. All right, now it's algebra 1 time. I need to solve for y, so what do I do next? I add 4 to both sides, so I get 2y equals 1/2 to the x minus 3/2 plus 4. And notice I did a switcheroonie. I put my 2y on the left-hand side. And then the last thing I need to do, divide by 2. Now, instead of dividing by 2, because that's going to look ugly, I'm going to go ahead and multiply both sides by 1/2. Is that the same thing? Yeah, and I'm actually going to show that. So I'm going to get y equals, and then if I distribute the 1/2, I'll get 1/2 times 1/2 to the x minus 3/2 plus, what's 1/2 times 4? 2, yeah. Now you could stop there, but you could also do something else. Notice that my a value and my base are the same number, aren't they? So when I'm multiplying and the base is the same, what can I do with the exponents? No. When the bases are the same, I add them, don't I? So I can now give it the name f inverse of x, and I'll go ahead and add those. I'll say it's 1/2 to the x minus 3 over 2 plus 1th power. Oh, that's kind of an ugly exponent. And then plus 2 down there. I don't know if that's any prettier. I could actually split up the x minus 3/2 and then combine the constants if I wanted. But we'll stop right there. Yeah, we'll stop right there. Now, if I wanted to answer part C, now it says, what's the domain of f inverse? What type of function is f inverse? What type of function is this? Is it a polynomial? No. Is it a log function? No. If it's an exponential function. It's an exponential function. And what's the domain of all exponential functions? All real numbers. And that's the range of all log functions, isn't it? Because they're inverses. Hey, guess what, gang? We're done. We finished. So, what am I going to, let's see. I think I put it in this morning into Canvas, the due date. Yeah, your homework for this section, I made it due Monday, not at 9 a.m., but Monday at 4 p.m. So that gives you something to do. I have a doctor's appointment on Monday, so I actually won't be here. So the sub will hand you your quiz. You'll take your quiz. You'll have the whole period to take the quiz. But whatever time you have left at the end, if you're not done with your homework, you can work on your homework the rest of the time. And it'll be due at 4 p.m. 4 p.m. instead of 9 a.m. So you have basically the school day to get it done. Does that make sense? Okay. All right. Any comments or questions? Logs? This is your first taste of logs. Logs still do a lot more than what we've seen so far. We're just introduced to logs. But logs, more logs are on the horizon. Yay, logs.